everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with chapter number 3, that is your machine level representation of programs. In the yesterday's class, I have finished with topic number 6 or 7, that is your procedures. Today I'm going to continue with topic number 8, that is your arrays in C. So first let's take quick review of the previous class, that is your yesterday's class. In yesterday's class we have discussed about the procedures, what is the procedure and how we can use the procedures. So procedure is a sub-program or a mini program that we can use while using the function code while using the coding of the C language. So it is a subroutine or the sub-program of the main program by which we can use the same code in a multiple places. Means we can reuse the code and we can maintain the code in a better way. That is your procedure. Procedures are or subroutine are very important in assembly language. This is your syntax of procedure, that is procedure name, procedure body, and then there is a return type. Then we have also discussed what are the multiple parts of a procedure, that is declaration, coding part, return directive, and termination of the procedure. Then we also discussed how we can use the procedure, that is what is the importance of procedure that is used for writing the reusable and maintainable code in assembly and high level languages. So these are the multiple methods how we can implement the procedures, that is done by either using the application binary interfaces, calling conventions, recursive calls, and there is a examples. These are the multiple concepts which we have studied yesterday. This is your stack data structure, that is how we can use the stack data structure. So stack is nothing but a procedure or a memory location in which we can store the data by using the LIFO method, that is last in first out. And we uses two operations, that is your push and pop for stack. Push means adding or inserting the values into the stack, and pop means removing the value or retrieve the value from the stack. So whenever we insert the data, that is known as push. So whenever we retrieve the data, that is known as pop. This is your push operands. This is the syntax: push operand, pop, register or address. Then we also talked about the examples. This is a push. So means whenever we want to insert or whenever we want to perform any operation, so first of all a push will perform, then move the data from value 1 to the register AX, then at last restore the original value, that is pop the values or retrieve the values. So first of all push operation, then move the operations or move the data, then there is a pop operation, that is retrieving the data. This is the syntax for stack. Then how we can use the stack. Then what goes into the stack frame means what is the content or what are the contents of the stack frame. This is your register usage convention. What are the registers used for stack? Then we also talked about the recursion. So whenever a procedure calls itself again and again multiple times, that is known as recursion or that is known as recursive procedure. This says a recursive procedure calls itself either directly or indirectly. In direct recursion, a procedure calls itself directly. Means, for example, if there is a procedure P that calls itself, that is known as directly, that is known as direct recursion. And if a procedure calls indirectly to the same procedure or to itself, that is known as indirect recursion. For example, P calls to procedure Q, Q calls to procedure P. Means in turn P calls, but P first of all calls to Q, then Q in turn calls to P. So this is your indirect recursion. And the best example is that whenever we use the factorial, that is 5 factorial, that is done by the recursion, that is 5 into 4 into 3 into 2 into 1. That is known as recursion. Then this is the syntax or this is the example how we can use the factorial. Then what are the problems that we use or that we face while using the recursion? There are two types of problems generally, that is inefficiency and increase memory location. Inefficiency means it introduce duplicate data while using the recursion. Then there is an increased memory location, means the memory capacity is also increased while using the recursion, as the same value is retrieved or same value will stored again and again. So that requires a increased or huge memory location while using the recursion. These are the examples that we discussed. This is your factorial example. This is your coding part of the factorial. This is your assembly language example. So that's all for yesterday's session. Today I'm going to continue with your next topic, that is arrays allocation and access. This is your A topic, that is array allocation and access. So let's start with the main topic, that is array is in C language. Arrays is a homogeneous collection of data type or homogeneous collection of data. That is, homogeneous means similar. So whenever we combine the similar data type values, that is, if there are 4 values and 4 values are of type int, that is known as array. So arrays is a collection of homogeneous data type. Suppose I am using int 4, that is 4 values that have a type int, that is of integer type, that is known as the array. This says C programming language provides a data structure known as array, which can store a fixed size sequential collection of elements of the same type. As I told you, it is of the same type. It's stored in a sequential location. That is first one, then next, then second, means there is no gap in between the numbers of the array. They are stored in a sequential order. An array is used to store a collection of data, but it is often more useful to think of an array as a collection of variables of same type. As I told you, it is of similar data type. If there is an int, all the 4 values are of the type data type int. Means if I am using 5 values, all the 5 values are of the type int, or the same data type, double, int, float, any data type, but it is of same type. Then it is saying instead of declaring individual variables such as number 0, number 2, number 1 and number 99, we can use the variable, that is array variable, such as numbers, and use number 0, 0, 1, 2, 99, that is 0, 1, 2 and so on till 99 are known as index. This says a specified element in an array is accessed by the index. So this is known as index, this is known as index, this is known as index. This is your first element, that is the starting point is your first element of the array, and the ending point is your last element. This says the lowest address correspond to the first element and the highest address correspond to the last element. Next, how to declare the array. This is the syntax. First of all, type, then array name. Type means data type. It may be int, it may be float, it may be double. So for example, I'm using double balance 10. This is your array size. It is a numeric value, that is 1, 2, 3, 4, 5, 6 till any values, that is 10, 20, 30, 40, any number of values. So if I'm using double balance 10, this is double, this is balance, this is 10. This stores, balance is a variable array, balance is a variable array which is sufficient to hold up to 10 double number. This is 10, this is double. So it is sufficient to hold 10 double number. The data type is double. This is how we can initialize the value. This says you can initialize the arrays in C either one by one or using a single statement as follows. This is double balance 5, that is 1000, 2.0, 3.4, 17, 50. This is how we can store. Balance is your variable name, that is array name. Double is your data type. 5 is your numbers. That is, there are multiple 5 numbers that have a data type double. That's why it is in decimal. 1000.0, 2.0, 3.4, 17.0 and 50.0. This says the number of values between braces cannot be larger than the number of elements that we declare for the array between square bracket. So these numbers are declared using braces. These are the braces, curly braces, and these are the numbers that are denoted by a square bracket, that is 5. So double balance 5 equals to these numbers. So this says these numbers cannot be larger than this value. If there are 5 numbers, this is 5, and if there are 6 numbers and I am using 5, so this gives an error. Means the number of elements are not more than that what we declare within the square bracket, and vice versa is not true. Means if the elements of the number of elements are small than the number what we declare in the square bracket, then it's okay, it's fine. For example, if I am using 4 variables or 4 numbers and here it is specified 5, so it is okay. I am using 4 number but I am specifying 5, one addition number, so that takes memory location but does not give any error. This says if you omit the size of the array, an array just big enough to hold the initialization is created. Means if you omit the size of the array, you forgot to give the size of an array, this is blank. So this takes any number or any type of values or multiple numbers of values that you have or that you need, that is your double balance. This is multiple number. You will create exactly the same array as you did in the previous example. Next is your statement. This is balance 450, means picking the value of 5th location, because as I told you, arrays always start with 0 location. So it is 4, means starting with the 0 till 4, that is your 5th location. So this is your 5th location, this is 0, this is 1, this is 2, this is 3, and this is your 4th location, and the values is your 50, that is at 5th location from this one, but it starts with 0, so this is according to the array, this is at 4th location. This says the above statement assigns elements 5th in the array a value of 50. As I told you, array with 4th index will be the 5th one, that is last element, because all array have 0 as the index of the first element, which is known as the base index. Following is a pictorial representation. This is the pictorial representation, how we can address or how we can represent. This is your balance. This is at 0th location, 1st location, 2nd location, 3rd location, and 4th location. So at the 0 location, this is 1000. At 1st, it is 2.0. At 2, it is 3.4, 7.0, and 50.0. These are the multiple location how we can initialize the values. Then how we can access the array elements? These are accessed by using the indexing the array names. This says an element is accessed by indexing the array name. This is done by placing the index of the element within the square bracket after the name of the array. So these elements are accessed by indexing the array name. This is the index. This is balance 9. That is balance 9. That is balance is a variable at 9th location. That is your 10th value is stored to the variable, that is salary. This is the explanation. The above statement will take 10th element from the array. 10th element, why? Because it is 9th and it starts with 0 till 10th element, and assign the value to the salary variable. Following is an example which will use all the above mentioned 3 concepts, that is declaration, assignment, and accessing. Next example shows all the 3 parts, that is declaration, how we can declare, how we can assign, and how we can access the array elements. This is the example. This contains initialization, access, as well as the assignment. So first part is your hash include stdio.h. Then this is your header file, that is include the header file, that is standard input output, and this is a header file, so that's why it is stored with the extension .h. Then there is a int main. that start with the main function, then int n10. This is the initialization of the array. That is, n is the array that stores 10 values. Then there are two variables, that is I and j. So this takes two variables, that is I and j. Then there is the initialization of the elements n to the 0. This is I equals to 0, I is less than 10, then I plus plus. This is the for loop. It starts with 0, it goes from 0 to 9, because this is less than 10, not 10. This is less than 10, so it starts from 0 and go till 9, that is from 0 to 9, then I plus plus. This is ni equals to I plus 100. So first of all, n0 means at the 0th location stores the value. This is 0, 0 plus 100 is 100. So at 0th location, that is n0 location, is only 100. Then next time I plus plus. This will increment. This is 1. Now n1, this is 1. 1 plus 100 is 101, that is 101. Then n1 is 101. Then I becomes 2, that is 2. This is 102, then 103, 104, 105, 106, 107, 108, 109, because it is going from 0 to 9. Then displays the output by using another variable, that is j. J is less than 10, j plus plus, uses element this, j, then nj. This is your example, element 0. This is element 0 location. The output is 100. Then at first location, this is 100, then 102, 103 till 109. This is how we can use in C language initialization, assignment and operations. Then C arrays in details. Till now we have covered the basics of the C language, that is how we can initialize, how we can access, and how we can assign the data in with the using of array elements. Then we have used how to use the C array in detail part. That is, arrays are most important to C and should need lots of more details. There are following few important concepts related to an array which should be clear to the C programmer. These are the multiple array concepts that we deal in detail. That is, first one is your multi-dimensional array. Means whenever we use more than one column and more than one rows, that is known as multi-dimensional array. This says C supports multi-dimensional arrays. The simplest form of the multi-dimensional array is the two-dimensional array. Two-dimensional array means more than one row and more than one column. Then next is your C category, or next concept is your passing arrays to a functions. Then returning array from a functions means pass the array to the functions, means passing the values as an multiple values to the functions, and also returns the values from the function as a multiple value, that is returning arrays to a function. Then pointer to an array, we can also declare a pointer. A pointer is a variable that stores the address. So we can also declare, or we can also access, or we can also generate a pointer to the first element of an array by simply specifying the array name without any index. Then this is a new concept, pointer. So let's take a quick review of the pointer. This is your main topic. This is your according to the book, this is your 11 topic or 9 topic, but here concepts of pointers is used. So let's take a quick review of the pointer. What is pointers in C language? So this says a pointer is a variable whose values is the address of another variable. Means the value that pointer stores is the address of another variable. A simple variable stores the value, but the pointer stores the address of the another variable. That is direct access of the memory location. Like any other variable, you must declare a pointer before you can use it to store any other variable address. The syntax is type star var name. Here type is the pointer base type, it must be a C, valid C data type, and var name is the name of the pointer variable. This is your int pointer IP. That is, IP is a variable that stores the pointer or that stores the address of the type int. This is double DP, double star DP. So DP is a variable that stores the address of the type, address of the data type double. FP is a pointer that stores the address of the pointer of the variable that have a type float. So in the same way, we can also declare for char. Now let's see in your book, what is the content of your book. This is array allocation and access. This says arrays in C are one means of aggregating scalar data into larger data types. Means whenever we add or whenever we sum up multiple contents, that is done by the C language. So whenever we combine more than one data of similar data type, that is done by the arrays in C language. This says one unusual feature of C that we can use or we can generate pointer to elements within array. Means we can access or we can use the pointer within the array. These are the basic principle how we can declare. As I told you, this is the char A. Array is the array that have a values 12 and that is of type char. Double is the array, C is the array that is of type double and that contains 6 elements. Now, next is your pointer arithmetic. Pointer arithmetic means how we can access or how we can use the pointers with the C language. This says C allows arithmetic on pointer. Arithmetic means arithmetic operations like plus, minus, divide, multiply. So we can perform arithmetic operations on pointers where the computed value is scaled according to the size of the data type referenced by the pointer. Means where the computed value means where the outputted value is scaled according to the size of data type referenced by the pointer. Suppose I am using int and if I am adding 1, so it is increased by 2 bytes because int takes 2 bytes. This is not increased by the value, but that is increased by the type of data type, by type of the bytes that our data type requires. If int takes 2 bytes, so it is added up to 2 bytes, 2 byte, 2 byte, 2 byte, means addition of 2 bytes. And if it is of 4 bytes, then it is the addition of 4 bytes. This is the example. Now let's see in your slides. This is pointer arithmetic. So this says when we add to a pointer such as p plus 1, we don't literally add 1 to the pointer address. Means we don't literally add 1, that is numeric 1 to the pointer. Instead we are adding 1 address. As I told you, if int takes 2 bytes, so we are adding 2 bytes to the variable or 2 bytes to the data, but we are not using or adding 1 to the data or 1 to the variable. So this is when we add a pointer such as p plus 1, we don't use or we don't add 1. Instead we add 1 address or we are adding 1 address to the pointer. This is a syntax, that is int list 1 2 3 4 int pointer p equals to list. This is a declaration of the array. List is the array that have a data type int that have a values 1 2 3 4. This is int pointer p equals to list. That is, p is a variable, p is a pointer variable that stores the values of the list, and list is also an array. So that stores the values of int type of p type of the variable t. That is same as p equals to ampersand list 0. Then printf the values of p. This is how we can printf the values of p. This is at 1st location, 2nd location and 3rd location, then 4th location. Then there is a 2D array. In book, there is a nested array. So let's take 5 minutes break. Today the session is so small. So let's take only 5 minutes break and then come back and then start with the topic, that is nested array. So today only, this is only 5 minutes break. Please come back within 5 minutes. So let's take 5 minutes break. Let's start with next topic, that is your nested arrays. So let's start with nested array. This is your book. This is your nested arrays. Means array within the array. So whenever we use array within the array or more than one array, that is known as nested array. This says the general principle of array allocation and referencing hold even when we create arrays of array. As I told you, whenever we create array of the array, that is known as nested array. For example, int a53, that is I'm creating 5 rows and 3 columns. That is int a is a variable name, int is a return type, data type, 5 is the number of rows and 3 is the number of columns. This is the equivalent to type def, that is we can declare or we can define the type up to 3, that is 3 rows, and we can declare the columns up to 5. So this is row 3, this is row 3 A5, that is column equals to 3 and rows equals to 5. This says data type row 3t, that is row 3t is defined to be an array of 3 integers because it contains t3, that is it contains 3 integers. Array A contains 5 elements, each requiring 12 bytes. This is your 5 elements, each requiring 12 bytes to store 3 integers. The total elements is 4 into 5 into 3, that is your 60 bytes. These are the multiple figures, that is A00, A01, A02, A10, A11, A12. As I told you, there are 5 rows. These are the 5 rows and these are the 3 columns. This is from 0 to 4, 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, like this one. This is your array, 5 rows and 3 columns. This is your 0, 0, then 0, 1, then 0, 2, then 1, 0, then 1, 1, 1, 2, this is 2, 0, 2, 1, 2, 2, this is 3, 0, 3, 1, 3, 2, then 4, 0, 4, 1 and 4, 2. This is 5 rows and 3 columns. This is 5 rows and 3 columns till 4, 2. This is how we can implement the nested array, means how we can use the nested array, that is array within the array. This ordering is a consequence of our nested declaration. This says viewing A is an array of 5 elements, each of which is an array of 3 integers. We first declare have A0 followed by A1 until so on till A4, 2. This is our array declaration, Dij, that is xd plus L Ci plus j. Now let's see with the help of slides. This is the 2D array, that is how we can use the 2D array, that is int my matrix 3 4 1 2 3 4 5 6 7 8 9 10 11 12. So these are the 3 rows and 4 columns. There are 3 rows. This is 0 1 2 and 4 columns means 0 1 2 3. This is 1 2 3 4. This is 5 6 7 8. This is 9 10 11 12. This is at 0 1 location, as I told you. So this is my matrix. Here my matrix is the name of the matrix or the name of the array. So this is your name of the array. This is your return type. I am writing this is your return type. This is your return type and this is your name of the array, right? These are the rows and these are the columns. This is the name of array This is the name of the array, right? Then this is the return type, this is the rows, this is the column. So this contains 3 rows and 4 columns. 3 rows means starting with 0 and ending with 2, that is 0 1 2. 4 columns means starting with 0 and ending with column 3, that is this is 0 0 location, this is 0 1, this is 0 2, and this is 0 3. In the same way, 1 0 1 1 1 2 1 3, 2 0 2 1 2 2 2 3. This is at 0 1 location, 0 1 location. 2 3, that is second and third location, that is second row and third column. This is 2 3, this is 12. This is your 0 row and first column, this is first column and 0 row. And if I want to use this one, 6, this is a first of all row, first row, and then column is also first, so this is 1 1. In the same way, this is 2 2, because second row second column, this is 1 3, because this is first row and third column. So this is how we can use the 2D array or the nested array, that is array within the array. This is physically in one block of memory. This is physically we can store. This is 2 4, that is 2 rows and 4 columns. That is 0 1 0 1 are the rows and 0 1 2 3 are the columns. That contains values 1 2 3 4 5 6 7 8. That is 2 rows and 4 columns. This is row 1, this is row 2, this is 0 row, and this is first row. That contains 4 columns, that is 1 2 3 4. That contains 4 columns, that is 5 6 7 8. This says array elements are stored in row measure order, that is row 1 first, followed by row 2, row 3, and so on. This is row 1, this is row 2, then row 3, and so on. Now, next is your 2D array name and addresses. This is the name of the 2D array. How we can declare? By using the 2 square brackets. This is the array name, this is the return type, this is the format for rows, this is the format for columns, and both are denoted by square brackets. So this is 2D array name, this is the array name and their addresses. These are the addresses. This is the memory address, which I am not using, you are not using, but using the computer. This is your memory address of 1, memory address of 2, memory address of 3, memory address of 4, 5, 6, 7, 8. So the first location, at first location, this is your memory address, this is your memory address, this is your memory address. So how we can declare? First of all, there is a return type, then there is a array name, that is my matrix. There are 2 square brackets, one is used for rows and one is used for columns, that is 2 4. Here there are 2 rows, that is 0 1, and 4 columns, that is 0 1 2 3, and that contains 2 parts, 1 2 3 4 5 6 7 8. Now this is the explanation. My matrix is the array name that is pointed to the first element of the 2D array, because there is no index in this, so it points to the first element of the 2D array, that is this one. If I am using 0, it points to the first row of the 2D array. Here there is no 0, there is no 1, so it's point to the first element of the 2D array. Then next one is your 0, means the inbox is 0, so it points to the first row of the 2D array. First row means that is a 0 row. Then my matrix 1, that is point to the second row, that is your first row, because it starts with 0 to the second row of the 2D array. Then pointer my matrix 1 is the address of the element my matrix 1 0. So this is your pointer, that is the address of the element 1 0. So this is how we can give the name and address of the arrays. Now how we can access? This is the way how we can access the addresses. How we can access? This is int matrix 2 4. same 2 rows, 4 columns, 1, 2, 3, 4, 5, 6, 7, 8. This is the way how we can access. This is indexing my matrix ij. I is the number of rows and j is the number of columns, is same as pointer my matrix I plus j, pointer my matrix plus I bracket close j. These are the multiple syntaxes how we can access the array elements. This is your declaration part. That is hash define rows 3, means we have defined that we are using only 3 rows, and we also defined that we are using only 5 columns. That is rows are from 0 to 1, that is 0, 1, 2, and columns are from 0 to 4, that is 0, 1, 2, 3, 4. Then we are using a array name table, and that our return type int, that our rows and columns. Then we are using a function that is void display table, means displaying the contents of the array that is known as table. This is the syntax, or this is the explanation for the using the, this is your calling function, this calls the function, and this is your definition of the function. This says 2D array often requires nested loop, that is 2 variable. This is your nested loop. So whenever we use the 2D array, that is array within the array or more than 1 rows and column, so it is mandatory to use nested loop, means loop within the loop. Now here if you see, we are using 2 loops. One is outer for loop, another one is inner for loop. So we are always using, or we always use nested loop while using the 2D arrays. So first of all, start with void display int x rows columns. So display is the function name, void is the return type, these are the arguments. Arguments are x rows and column. X is your array name, these are the multiple index, that is rows and column, this is your return type. So first of all, starting with the loop 4 statement. First one is int I equals to 0, that is starting with the 0, I has a value 0, then I is less than rows. That is for example, if user is defining the rows 4, so the first loop, that is outer loop, will terminate till 4, that is from 0 to 4 or from 0 to 3, that is 0, 1, 2, 3, because it is 4. For example, I am taking the example. If the rows are 3 and the columns are 4, for example, so the rows are 0, 1, 2 and columns are 0, 1, 2, 3. So this is rows, this is 3 and this is 4. So first of all, outer loop terminate till 2, that is 0, 1, 2, and this loop will terminate till 4, that is 0, 1, 2, 3. So starting with the first loop, that is I equals to 0, I is less than rows, I plus plus, goes to the inner loop, that is j equals to 0, j is less than columns, j plus plus. Here the condition is true, go to the another loop, here also condition is true, then print x percentage d percentage d percentage d ij. I has a value 0, j has a value 0, and the x j I j. Now xij means x at the 0 location and x at the 0 location of z, that is x00, that is at the 00 location. Then move to the next line. Again loop will go to the outer one because this is the termination. First of all, go to the beyond the loop, goes to this one, inner loop. Here my pen is not working, otherwise it's very good. So I'm repeating again. First of all, outer loop will execute. That is, we check the condition till rows. How we can use the rows? How we can access the rows? The condition is that till the rows, that is, if I'm specifying 3, so it will execute from 0 to 2. Then it goes to the inner loop. That is your columns part. This is your line. Now this is a curly brace. Now cursor will move again to this part. From this to this part, not from this to outer part, not from this to outer part, not from this to outer part, but it uses with this to this part. Right. So this is again go to this one. Now j becomes 1. Condition is also true, as I am showing example its columns are 4. 0 is 1 is greater than or 1 is less than 4. If 1 is less than 4, again print ij x 0. Now I is only 0 but the j is 1. So this is placed at the 0 1 location. Then again goes to this loop. Now j become 2. Condition is again true. 2 is less than 4. Then print ij, that is 0, and 2. This is 0 2. That is x location at 0 2. Then again goes to this part. Now j become 3. This is 0 3. This is x 0 3. Now goes to the 4. J become 4. Here the condition is false because the 4 is not less than 4. It is equals to 4 but it is not less than 4. So now this loop will terminate. This curly brace will terminate and you can use printf /n, that is used for moving to the next line. Now my cursor moves to the next line, then goes to the outer loop. Now I becomes 1 because I plus plus, I becomes 1, j becomes 0. Go to the inner loop. Condition is true. As I told you, this is rows. 1 is less than 2 or 1 is less than 3 if I am using 3. The condition is true. Goes to the inner part. Now j equals to 0. So this is 0 and 1. This is 1. This is 0. This is 1 0. In the same way, this will execute. This will execute till the I become 3 and the j become 4. This is how we can use the inner loop as well as the outer loop. So the main crux is that whenever the inner loop will not terminate, with the R cursor will not goes to the outer loop. So first of all, inner loop will terminate, then goes to the outer loop. So yes, I will repeat the steps, but not today, for tomorrow, because I think it's already time is over. So I'm repeating this again, but not in today's class, in tomorrow's class. So I think that's all for today's session. I will wind up, or I'm winding up at this stage, but this topic is not completed yet. So I'm going to continue with this same example tomorrow. But today, I'm so sorry for this. The class will disturb it due to some confusion of the links. But I'm sure this will never happen in the future. But that's all for today's session. Tomorrow I'm going to continue with the same topic, that is array. And if you have any doubts till now of 1 hour lecture, then please mail me the doubt or text me the doubt and I will answer you. So that's all for today's session. Thank you so much everyone.